pressure drop, pressure loss and head loss. They seems to be similar but have different meaning, which seems confusing at first, but it would be clear if you understand how the energy balance works, which is the Bernoulli's equation. I am expressing them in term of heights. Each term of this equation have the dimension of length, and represents some kind of head, of a flowing fluid. First one is the pressure head. It represents the height of a fluid column, that produces the static pressure, P. For ideal flow along a streamline, with no change in height, an increase in velocity, results from a decrease in static pressure. Remember, I said ideal fluid, that means no any losses or friction. So, for fluid to flow in right direction, the pressure at point 1 should be greater than pressure at point 2. And the pipe is horizontal, so there is no datum height effect. So in order to balance the energy equation, velocity must increase at point 2. This is the law of conservation of energy. And this difference in pressure between 2 points is called pressure drop. Fluid particles accelerate due to pressure difference. Now, do you know what might happen if pressure at point 2 is greater than pressure at point 1? Of course, the fluid particle will travel from right to left direction. Did you see how the pressure difference or drop between those 2 points determine the flow direction? This is reversible pressure drop, without any irreversible losses. But, in real life there exists irreversible pressure drop, because there is always presence of friction and heat. So the static pressure will decrease even more, along the length of pipe, not only because of increased velocity, but due to friction effect too. The height of liquid column drops even more, due to friction. So the loss of liquid column height, due to friction effect or other irreversible effect, is called head loss. As you can see, head loss affect the energy balance. This loss is permanent and not conserved. It lost to the surrounding. So, how can we overcome this head loss? Now, here comes the role of pump. With pump we can give extra energy to the fluid that can overcome head loss. Then again we come back to the ideal fluid state. If you look at the energy of an ideal fluid with the frictional fluid, you will find out that the pressure drop is reversible on ideal fluid, whereas on frictional fluid, pressure drop is somewhat irreversible. Some pressure is lost due to friction, and cannot come back. And this is pressure loss. In the analysis of piping systems, pressure losses are commonly expressed in terms of the equivalent fluid column height, called the head loss. So pressure loss and head loss are related with this equation. Now, let's add turbine too, and extract some of this fluid energy. Turbine drops the pressure and velocity even more. So for energy balance, if we calculate the pressure difference or pressure drop, then see how the pressure drop varies with the initial and final velocity of fluid, the change in datum height and the work done by a pump or turbine, and the pressure loss. If you look at this equation properly, pressure drop will be equal to pressure loss when the velocity and datum change is constant and there is no pump or turbine work.